Okay guys, we are now at Unit 7, Object-Oriented Data Modeling and Data Abstraction. As we have learned last time in Unit 6 about Venn and Grossfoot diagram, basically this unit is related to Venn and Grossfoot diagram in the sense that we are also creating a diagram, but this time based on the object-oriented data modeling idea. So for this unit, we are going to answer the following questions. Question number 1, what are the different types of object-oriented data model? How can we create a unified modeling language diagram? And what are the levels of data abstraction? Basically, these questions are related to our lecture for Unit 7. For our intended learning outcomes, they are the following. The types of object-oriented data models and how do we create them, and the process of creating a UML diagram using software tools. Okay, when we say OODM or object-oriented data model, both data and the relationships are contained in a single structure known as an object. In turn, OODM is the basis for the Object-Oriented Database Management System or OODBMS. The OODM is said to be a semantic data model because semantic indicates meaning. Basically, it is a data model that defines our particular database. The object-oriented data model is based on the following. Number 1, an object is an abstraction of a real-world entity. An object may be considered equivalent to an entity relationship model's entity. More precisely, an object represents only one occurrence of an entity. So basically, they are the same as the entity of Chen or Grossfoot. Next, we have attributes. Attributes describe the properties of an object. For example, a person object includes the attributes name, social security number, and date of birth. Number 3, objects that share similar characteristics are grouped in classes. A class is a collection of similar objects with shared structure or attributes and behavior or methods. A class resembles the entity relationship model's entity set. However, a class is different from an entity set in that it contains a set of procedures known as methods. A class method represents a real-world action such as finding a selected person's name, changing a person's name, or printing a person's address. In other words, methods are the equivalent of procedures in traditional programming languages. Methods define an object's behavior in object-oriented terms. Number 4, classes are organized in a class hierarchy. The class hierarchy resembles an upside-down tree in which each class has only one parent. For example, the customer class and the employee class share a parent person class. Okay, so basically, customer and employee are under the person class. Inheritance is the ability of an object within the class hierarchy to inherit the attributes and methods of the classes above it. For example, two classes, customer and employee, can be created as subclasses from the class person. In this case, customer and employee will inherit all the attributes and methods from the class person. Object-oriented data models are typically depicted using Unified Modeling Language Class Diagram or UML Class Diagram. Unified Modeling Language is a language based on object-oriented concept that describes a set of diagrams and symbols that can be used to graphically model a system. UML class diagrams are used to represent data and the relationship within the larger UML object-oriented system modeling language. The class diagram is a static diagram. It represents the static view of an application. The class diagram is not only used for visualizing, describing, and documenting different aspects of a system, but also for constructing executable code of the software application. Basically, the class diagram can help serve the database designers in properly designing objects such as tables or codes inside our database. Just like how it would help a programmer define all the needed forms, actions, and methods inside our program. That is how a class diagram helps in database development. The class diagram describes the attributes and operations of the class and also the constraint imposed on the system. The class diagram are widely used in the modeling of object-oriented system because they are the only UML diagrams which can be mapped directly with object-oriented languages. The class diagram shows a collection of classes, interfaces, association, collaboration, and constraint. It is also known as a structural diagram. Now, what are the purpose of a class diagram? The purpose of the class diagram is to model the static view of an application. Class diagrams are the only diagram that can be directly mapped with object-oriented languages and thus widely used at the time of construction. UML diagrams, like activity diagrams, sequence diagram can only give the sequence flow of the application. However, class diagram is a bit different. It is the most popular UML diagram in the coder community. The purpose of the class diagram are as follows. Analyze and design of the static view of an application or our database. Describe the responsibilities of a system or a database system. The base for component and deployment diagram. Forward and reverse engineering. When we say reverse engineering, it means going back from the output to the code. Okay, that is reverse engineering. Forward engineering, meanwhile, pertains to creating code using diagram. So basically, from the diagram, it turns into code that is what we call the process of forward engineering. Now, how do we draw a class diagram? Class diagram are the most popular UML diagrams used for the construction of software applications. It's very important to learn the drawing procedure of the class diagram. They have a lot of properties to consider while drawing, but here the diagram will be considered from a top-level view. The class diagram is a graphical representation of the static view of the system and represents different aspects of the application. A collection of class diagram represents the entire system or the entire database system. The following points should be remembered while drawing class diagram. The name of the class diagram should be meaningful to describe the aspect of the system. Each element and their relationship should be identified in advance. Responsibilities, such as attributes and methods of each class, should be identified. For each class, the minimum number of properties should be specified, as unnecessary properties will make the diagram complicated. Use notes whenever required to describe some aspect of the diagram. At the end of the drawing, it should be understandable to the developer or the coder. And finally, before making the final version, the diagram should be drawn on plain paper and reworked as many times as possible to make it correct. So the following diagram is an example of an order system of an application. It describes a particular aspect of the entire application. First of all, order and customer are identified as the two elements of the system, so customer and order. They have a one-to-many relationship because a customer can have multiple orders. Take note, you can also use the symbols that we have learned from Chen. Okay, so basically we could also use M here. But notice the line. The line contains an arrow, which we will explain later on. Basically, this arrow represents a meaning. Okay. Order class is an abstract class, and it has two concrete classes for inheritance relationship called special order and normal order. Basically, order class is an abstract class, meaning it's like a blueprint in which two classes are created, namely special order and the normal order. Because this is an inheritance or generalization, all the properties found in the order class can be found in the concrete classes or in the derived classes. Okay. We can also find the properties that they have are the same. UML class notation. A class represents a concept which encapsulates state or attributes and behavior or operation. Each attribute has a type. Each operation has a signature. The class name is the only mandatory information. Take note, the only mandatory information when defining a class diagram is the class name. Okay, basically it will not be a class diagram without the class name. All the other details such as attributes or operations can go except for the class name. Otherwise, without the class name, it will not be considered a class. Okay, class name. The name of the class appears in the first partition. Take note, our object used for defining a class diagram is a square. Okay, it is divided into three parts. So on the topmost part is the name of the class. Next, on the second part of the partition are the class attributes. Okay. The attributes map onto member variables in code. Okay. Basically, in the attributes, we can also define what particular data type that attribute has. So in this instance, we have length, which is an integer data type. Next, on the final part of our diagram, on the third partition is the class operation. They are services the class provides. Basically, these are the methods or the actions found in our um, classes. So for this example, we have get length and set length. Okay. We can also define the data type after the particular class operation by using a colon. Operations map onto class methods in code. So in this example, my class name has the attributes, so attribute 2, and attribute 3. And then they have three particular return type, int, float, and circle. For the third partition, we have here the methods. So we have method of 1, which returns string, of 2, returns float, and of 3, which returns class 6. Okay. As you see here, you can also see the parameters employed by the method. Next, class visibility. The plus, minus, and sharp symbols before an attribute and operation name in a class denotes the visibility of the attribute and operation. When you use the plus sign, it is a public attribute. When we use a minus sign, it is a private attribute. And when we use a hashtag sign, it is protected attribute. Okay. Public, as you all know, can be seen by what? It can be seen by the members of the class, while the private attribute can only be seen inside that particular method that use that particular attribute. Whereas when we say protected attributes, some part of that particular attribute can be accessed within the class and by other classes. So let me repeat. When we say private attribute, which is symbolized by plus sign, can be accessed within the class and outside of the class. When we say private attribute symbolized by minus sign, can only be accessed within the class. And if we say protected attributes, which is symbolized by percentage or hash sign, it means that it can be accessed inside the class and it can also be accessed outside of the class. Okay. Parameter directionality. So when we have parameter in our methods, we can have the following direction, which can be in or out. Basically, when you say in, it accepts the value and it gives the value to the particular parameter name. In this case, in P1. So once we give out a value, that particular value will go to P1. Okay. We also have an out parameter. Basically, an out parameter tells us that we could return the value of that parameter once we execute our method. And then we have an in and out parameter wherein the parameter can be used inside that particular method as well as return particular method or return a particular value out after the method has been executed. So can both accept and it can both return. Okay, in parameter just accepts and uses the value for the properties or processes inside the method. The out, meanwhile, returns value once particular action or method has been executed, whereas in out can both be used to accept and return value. Perspective of a class diagram. The choice of perspective depends on how far along you are in the development process. During the formulation of a domain model, for example, you would seldom move past the conceptual perspective. Analysis model will feature a mix of conceptual and specification perspective. Design model development will typically start with a heavy emphasis on specification perspective and evolve into implementation perspective. A diagram can be interpreted from various perspectives. Conceptual represents the concept in the domain. Specification, the focus is on the interfaces of abstract data type in the software, and implementation describe how classes will implement their interfaces. The perspective affects the amount of detail to be supplied and the kinds of relationship worth presenting. As we mentioned above, the class name is the only mandatory information. So as you can see here, we have here conceptual, we have here the specification, and the implementation. Relationship between classes. So these are the various lines that we can use to represent the relationship between classes. So we have association, inheritance symbolized by arrow with a blank arrowhead. Realization, which uses dots and a solid arrowhead. Dependency, which uses dash and an open arrow. We also have aggregation, which uses a diamond, and composition, which is a black diamond. Inheritance or generalization. If you see at figure 7.8, we have a class inheritance example wherein the superclass, all the methods and properties available for the superclass can be passed down into the concrete or child classes. So basically, the methods and properties that is available on the parent can also be accessed in the child classes. Inheritance example, so shape. So we have here two styles of how we could draw the inheritance example. So this contains three separate lines pointing to the uh, parent class, and then we have here two lines which are converging, pointing to the parent class. We also have association, so signified by this symbol. Associations are relationship between classes in a UML class diagram. They are represented by a solid line between classes, typically named using a verb or verb phrase which reflects real-world problem domain. For example, a structural link between two peer classes. There is an association between class 1 and class 2. Okay, we also have cardinality, which tells us how many objects are concerned. We have one-to-one, one-to-many, and many-to-many. So in here, we make use of the symbol 0, 1, and 3. Aggregation, a special type of association. It represents a part of relationship. So class 2 is a part of class 1. Many instances denoted the the asterisk of class 2 can be associated with class 1. Objects of class 1 and class 2 have separate lifetime. The relationship is displayed as solid line with an unfilled diamond at the association end, which is connected to the class that represents the aggregation. We also have composition. It's a special type of aggregation where parts are destroyed when the whole is destroyed. Objects of class 2 live and die with class 1. Class 2 cannot stand by itself. Dependency. An object of one class might use an object of another class in the code of a method. The object is not stored in any field, then this is modeled as a dependency relationship. Okay. Here, special type of association exists between two classes if changes to the definition of one may cause changes to the other one. Class 1 depends on class 2. This is another example. Realization is a relationship between the blueprint class and the object containing its respective implementation. For example, the owner interface might somehow specify methods for acquiring properties and disposing of properties. The person incorporation class needed to implement these methods possibly in different ways. So I will not give out a very complex example or a very complex quizzes about UML. However, what I would want you to have is the knowledge on how we could write UML diagrams. because as a programmer, it will help you in the near future. In this example here, the order system, again, we have customer and order. Okay. Under aggregation or inheritance, okay, we have the order detail. And then also, under the order detail, we have what type of relationship. We have a dependency. We have a dependency here. So order detail depends on the item. Okay. Another inheritance that we can see here is under payment, which are dirty type, cash, check, and cards. Now, under order, there is the class payment. So this is an abstract class. Why? Because an abstract class provides blueprint for the creation of new child class. Okay. Just kindly review those sample diagrams. Next, we have here a class diagram with notes. Okay. Basically, you can indicate the notes needed if you want to clarify something in your exam. When do you use class diagram? It is static and used to model the static view of the system. It describes the vocabulary of the system. It is considered as a foundation for component and deployment activities. Next, UML diagrams are not directly mapped with any object-oriented programming languages, but the class diagram is an exception. The class diagram clearly shows the mapping with object-oriented languages such as C#. From practical experience, a class diagram in general is used for construction purpose. Class diagrams are used for, number one, describing the static view of the system, showing the collaboration among elements of the talk, describing the functionalities performed, and construction of software applications using object-oriented languages. Let's now go into the future of data models. We have hybrid DBMS or hybrid database management system, which are emerging that retain the advantages of the relational model at the same time provide programmers with the object-oriented view of the underlying data. This types of databases preserves the performance characteristics of the relational model and the semantically rich progr- programmatic support of the object-oriented model. We also have the SQL data services such as Microsoft SQL Data Services on its Azure services platform, becoming a critical component of relational databases vendors' internet service strategies. This cloud-based or that is remotely processed and internet-based data services makes it possible for companies of any size to store their data in relational databases without incurring expensive hardware, software, and personnel costs, while having access to high-end database features such as failover, backup, high transaction rates, and global data distribution. Companies use them as pay-as-you-go system based primarily on their storage and bandwidth utilization and the features used. Now, data abstraction has different degrees. Okay, it is basically split into three parts. We have the physical, internal, and external models. Okay, when we say physical, internal, and external models, These are the following explanation. As you can see on figure 7.9, the external model is the end user's view of the data environment. Okay. So basically, the external model or the conceptual model, we would like to call it, are the view of the end user, or it is also the view of the designer. Okay. End users operate in an environment in which an application has a specific business unit focus. Companies are generally divided into several business units such as sales, finance, and marketing. The term end user refers to people who use the application programs to manipulate the data and generate information. So they are the external or conceptual model. It is how the end user view the particular data. So we will go back to this one later. Because data are being modeled, ER diagrams will be used to represent external views. A specific representation of an external view is known as an external schema. The conceptual model represents a global view of the entire database as viewed by the entire organization. That is, the conceptual model integrates all external views into a single global view of the data in the enterprise. Also known as conceptual schema, it is the basis for the identification and high-level description of the main data object. Basically, when you say conceptual model, all the external views found in the operation of a particular business or enterprise are compressed together into a single global view or into a single external view. So basically, conceptual model and external model are the same. However, when we say conceptual model, all it is a summary of all the external view already. Okay. Whether the external view is only one or many, conceptual model is the summary of the all the external view. Now, as we see here in figure 7.2, basically we use an entity relationship diagram to represent an external model. So, a conceptual model can have one or more external view or external model. So, in this example, we use a crow's foot, but we could also use a chain. Okay. We could also use a class diagram. However, if we are to use a class diagram, um, that particular class diagram is better suited if we are to develop an application for that particular database. Now, if we are only planning to create the flow of data as seen by the end user, it is better to make use of either a chain or a closed foot. So what we see here is student registration. For our figure 7.2 ER diagram, we have here student registration and class scheduling. Basically, we are making use of closed foot diagram in this example. We could also make use of a chain diagram if you want. In this example, a student may take up to 6 classes for registration. So the process is one student enrolls in one or many enroll, and one or many enroll is taken up by one class, and one or many class is generated by one course. Okay. So we have here the comments a student may take up to 6 classes per registration, and for the class, a class is limited to 35 students. For class scheduling, we have room. One room is used for one or many classes, and one or many class is generated by one course, and one or many class is being teach or is teach by one professor. A professor may take up to 3 classes. Each class is taught in only one room. Each class is taught by one professor, and a room may be used to teach many classes. So what are the advantages of having a conceptual or external model? Provides a relatively easy understood bird's eye or macro level view of the data environment, and it is independent of both hardware and software. Software independence means that the model does not depend on the database management system software used to implement the model. Whereas hardware independence means that the model does not depend on the hardware used in the implementation of the model. Therefore, changes in either the hardware or the database management system software will not affect the database design at the conceptual level. Basically, because this is how we see the flow of data. It never changes. That's why the conceptual level cannot be affected because it is the flow of data as seen by the actual user. Okay? It is independent of the software or the hardware being used. Generally, the term logical design is used to refer to the task of creating a conceptual data model that could be implemented in any database management system. Now, once we merge the figures found in figure 7.2, we will come up with this one. So one student enrolls in one or many. Enroll or enrollment, and one or many enrollment is taken by one class. One professor teaches one or many class, and one or many classes used for one room. One or many class generates one course. After the external model or the conceptual model, we will now go to what we call the internal model. The internal model is the representation of the database as seen by the database management system. The internal model requires the designer to match the conceptual model characteristic and constraint to those of the selected implementation model. Basically, we are turning the conceptual model into a data that is understood by the database management system that you are using. An internal schema depicts a specific representation of an internal model using the database construct supported by the chosen database. In figure 7.22, we are translating the entities or the objects from the conceptual model into the internal model. As you can see, basically this is code, create table, and then the table name together with the columns. Basically, we are turning the objects found in the conceptual model into an internal model with codes that are understood by the database management system. So if you run this code inside your database management system software, it will execute it and create tables with columns and data types inside your database management system. So this is dependent on the actual software, but since we are using SQL, which is standard language, almost all of this code will execute with little modification on almost all relational database management system software. So that is the internal model. Again, to recap, conceptual model is the model seen by the end user. The internal model is the a representation of the database as seen by the actual database management system software. And then lastly, we have the physical model. Physical model is operating at the lowest level of abstraction. It describes the way data are saved on the storage media such as disk or tapes. The physical model requires the definition of both the physical storage device and the physical access methods to reach the data within those storage devices, making it both software and hardware dependent. The storage structures used are dependent on the software, such as the database management system and the OS, and the type of storage devices that the computer can handle. The precision required in the physical model's definition demands that database designer who work at this level have a detailed knowledge of the hardware and software used to implement the database design. The physical model is dependent on the DBMS, methods of accessing the file, and types of hardware storage devices supported by the OS. When you can change the physical model without affecting the internal model, you have physical independence. Therefore, a change in storage devices or methods and even a change in the OS will not affect the internal model. So in figure 7.23, we can see here the degree of abstraction. The highest degree of abstraction is found in the external and conceptual model. Take note, the conceptual model is the summary or the sum of all external models. So some books use conceptual and external model as only one particular term. Okay. External or conceptual model, both are hardware and software independent. The internal model, on the other hand, is specific database model. It is hardware dependent, but software independent. As I have said, the sample codes are using SQL, which is standard in most relational database management system. And the lowest abstraction is the physical model, wherein it involves storage and access methods, and it is hardware and software dependent, meaning if you change the hardware, the physical model will change. If you change the software, the physical model will also change. So that's it for our lecture. On the next part, I will give you samples of how we can create object-oriented data models, how can we represent them, and also we will be looking at examples on how they can be used. However, we will not dwell on all the characteristics and properties of the object-oriented data model so as not to confuse you with the difficulty of creating those particular models. We will just introduce the basic concepts on how they are created.